Hello, and welcome to my short presentation of another assessment of anaerobic fitness. The physical assessment I chose is referred to as a maximal anaerobic running test, or MART. You will also hear it referred to as MARP with a P for maximal anaerobic running power. I prefer the term test rather than power because, as you will see, power is slightly difficult to determine for this test. It could be difficult to determine because this test is not a test of anaerobic capacity. Rather, it gives insight to capacity, I suppose, by testing various components associated with the anaerobic energy systems. And because of this, it is commonly utilized as an assessment of anaerobic performance. As you see on the slide, it was developed for evaluation of maximal anaerobic running power characteristics. It is used for insight into performance and does not measure capacity. And because of this, it is not applicable to the entire population. So throughout research, the test has been developed specifically for high-quality intermediate sprinters. I have in parentheses there the 400-meter. I suppose that this test could be used for 800-meter runners as well, as the 800-meter is an intermediate race. The article by Rusco, Numello, and Marrow is going to be the main article that I'll be deriving most of my information from, mostly because it was the easiest to understand. It was one of the original works, and most importantly, it was one of the original works that I feel may have blazed the trail for the rest of the protocols and inclusion criteria. So their aim was to develop a new lab test method that could be used to determine both metabolic and neuromuscular components of max anaerobic performance. They used 13 male athletes whose 400-meter times were between a high 47 and a mid 54 seconds. And if you know anything about 400-meter times for college athletes, especially Division I, these times, well, they're not that good. Division I 400-meter women runners often hit an average of 54 seconds. So this is kind of contradicting when I said the test was developed for high-quality intermediate sprinters. And then you see the subject pool they were dealing with. Bear with me, though. The runners were asked to perform a max 20-meter sprint speed test with a flying start and a max 400-meter time trial on a track a week before testing took place. This gave them something to compare. So what they found was significance in correlating max power and average speed in the 400-meter sprint, and max 20-meter sprinting speed and lactate levels, both correlating with max power and 400-meter speed. So with those results, they were able to conclude that the new method allowed evaluation of several determinants of max anaerobic performance. Let's talk about the equipment you'll need to perform the test. Nothing you shouldn't be already familiar with. You'll need a treadmill, you'll need that lactate meter, which we have been previously introduced to. You'll need some biohazard safety materials. This would include gloves, lab coats, glasses, alcohol wipes, etc. And you'll need 3 or more assistants. You'll need one to adjust the speed, one to obtain the lactate measurements, and a couple of spotters. I recommend 3, one on each side of the treadmill, and then one towards the back. And here in a little bit, when you're watching the video, you'll understand why I'm stressing the importance of spotters during this test. You'll see I have it underlined there. It is a high-speed treadmill test performed until exhaustion, actually past the point of perceived exhaustion, and I have a slide explaining what is deemed exhaustion for this particular test. So this is the equipment that you will need. As I mentioned, here is that lactate meter that should be memorable. It comes in a convenient case with all the necessary supplies, including the strips, the meter itself, as well as the lancet. Let's make it a point to address the 4.2 reading on this example, which would most likely represent a resting lactate level, and you will soon see how significantly this number can and will climb when performing high-intensity anaerobic activity. All right, finally, a protocol. I have there a personalized warm-up. Since this is a test attempting to achieve an expression of performance, you obviously want the subject to perform at their very best. So each and every sprinter has their own way that they like to warm up, that they perceive as most efficiently preparing themselves for their upcoming performance. So I urge you to allow an individualized warm-up. This warm-up is very important because the test does not allow a warm-up period like we are used to seeing sometimes for a VO2 max, the whole walk at 3 miles an hour for 3 minutes. Well, there's none of that here. The test just jumps straight into high-intensity work. So the speed is predetermined and the grade is kept constant at 4 to 5%. This gradient is acknowledged within the literature as being based on researchers' opinions that 5 degrees was to keep the maximal running speed low enough so as to avoid the risk of injury and to facilitate the attainment of maximal running power. The speed needs to be high intensity, like I said, and for the most part, an experienced runner is going to have a pretty good idea as to what they can and should start off at. Kind of like one knows they're around about 50% for a 1 rep max. So when the speed is determined, the subject runs at that speed for 20 seconds. There is a 5-second acceleration phase that is not included in the running time. So when the 20-second run is completed, the subject is granted a 100-second recovery time, and during this time, a lactate measurement is administered 40 seconds into that recovery time. The speed is then increased by 1 mile an hour, and yet another 20-second run is attempted once the 100-second recovery time is complete. You see that there is also a lactate measurement administered at 2.5, 5, and 15 minutes after test completion. It's done this way because not until after exercise is completed, you will actually see lactate levels rise to their highest degree, more around the 5-minute mark. Now, determination of exhaustion is interesting in this test. First, the basic definition is defined as the point where the participant can no longer run at the speed of the treadmill, but the participant will always be subjected to the next running speed. And in that Rusko article I've been citing, they state that from their experience, they see that an athlete who is just able to complete 20 seconds at a certain speed will always be able to run at least 7 to 9 seconds at the next faster speed. I thought that was funny, a little harsh, and very demanding. Anyway, if they are able to complete 10 seconds of the last run before exhaustion, their maximal power was calculated to be plus 1 mLs per kg per minute, and speed plus 0.5 miles per hour higher than that of the last completed run. Each additional 2 seconds until exhaustion increased the max power by the exact same increments. So like I said, here's that lactate reading that you can see the number has climbed significantly from a resting level to 19.6 millimoles, which certainly surpasses the mark of 10 millimoles that indicate max work. So here's the test. You see the subject running at one of her first stages, and then the little video down below you're going to see at a much higher stage, much more intense. This subject started out at 8 miles an hour and ended at about 13 miles an hour. You see her jump off the treadmill. Okay, so that stage is complete, that 20 seconds. And you see the assistant taking a lactate measurement. And it's not uncommon to take the measurement from the earlobe while one is exercising. So it may take a little bit, and you can see down in the video below again that the subject is getting a little tired. She's having to put her arms up on her head, and she's trying to shake it out a little bit. Right now we're still in that 100 seconds of recovery rest time, and you will notice that the assistant took the lactate measurement a little earlier than what he was supposed to, probably not about at that 40 seconds. You will also notice that there are no spotters around. I suppose we will just assume that these two were experienced enough that they didn't feel they needed spotters. So you can see she's getting ready. The speed has gone up 1 mile an hour, if you remember from the protocol. Still have quite a bit of time left for the 100 seconds of recovery period. You can see the assistant getting ready for the next lactate measurement. The subject is kind of getting a feel for the treadmill, getting a feel for the next stage, the next speed. And there she goes into the next stage. And this stage, like the others, will last 20 seconds. You see that the intensity has most certainly picked up. And she should be about done. Looks pretty relaxed. And there she goes. Same thing, taking that lactate measurement, and that 100 seconds of rest has begun. Some calculations here. Because mechanical power is pretty difficult to measure during treadmill running, the power for this test is expressed in oxygen equivalents using the formula of the ACSM, which we have used before, so that should be nothing new. So let's talk about if the test can accurately correspond to one's 400 meter. As you see there, the 400 meter time trial has shown velocity almost equal as in the MART test at exhaustion, suggesting good specificity of the test. Results have shown correlation analysis to indicate that the MART test measures the same determinants of performance as the 400 meter run on a track, suggesting that the test is valid. And an intensity of 110 to 190% of VO2 max has been determined during the test, which is considered to have exhausted the anaerobic energy stores in the ATP-PC and glycolytic systems. So we can consider this test a supermaximal test because it elicits power 2 to 4 times above a measured VO2. The MART test gives insight into anaerobic performance based on lactate levels and power expressed as VO2 in mLs per kg per minute. So, is this a good test? Well, sure it is, for a 400 meter runner or someone curious about what their 400 meter time may be. I chose this test because it pertains to me. Back in the day, not so much now, but it still interested me, and it was something different and something I enjoyed doing as well. So, thanks for listening, and I hope you found it enjoyable.